What's up, guys? You are coming in a little bit late on this project. We've just had so much going on that to be honest with you, I didn't have time to record. I was doing other projects. Just it's been a crazy week or two, and so I just got this welded up, and I'll show you what these are. We've actually got the old one outside, and we're able to get it, luckily, which we took measurements. I went and took measurements on site and quoted this job, and the good thing is I was able to go pick these up. That way we know when we're going through all this making these pieces, we get everything you know, spot on. So I've got this end put together. I'm gonna pull these clamps off. It's welded. This is all 1/4" stainless. This is all 1/4" plate stainless. These were 5x10 sheets, 2x2 1/4" stainless angle, 2x2 1/4" running down there. And we made this in 2 pieces, and I'll show you what they are. This is actually part of a water treatment facility. These massive things over here all get bolted together and ends up being about 35 feet. So this one here is just shy of 15. It's like 178.5 end to end, and then these two are exactly 120. So they're 10 feet a piece. And we're not making these splash pans. We do have to mount all the angles with the holes for them to bolt those. We're gonna reuse those. Those are aluminum. These, I don't know what these are called. They're like ripple things or ripple guards or something. These are actually fiberglass. Pretty cool. So they're gonna reuse all those. But this is what it is. So this all bolts together. This was put in, I wanna say like late 70s, early 80s, they told me. So this is way longer than I would have ever imagined. So you're 20 to 25 years, and this sets in water. This is part of the wastewater treatment facility. This sets in water 24/7, 365 days a year, not to mention some other stuff. This is the end of the line, so that's why I don't mind having these here. They're not really contaminated. There's some stuff that goes through them, but it's not the first part of the process where the bad stuff comes in. So but anyway, these were built out of steel, and how they've lasted this long, I have no clue, but they did. And as you can see, they're falling apart. So we've quoted it. We did. We're doing one, and there's 5 more just like this. There's 6 total in this part of the treatment plant, and we're hoping we'll be able to do the other one. So it's not too bad a job. But we've got all these pieces. As you guys know, I do not have a press brake, so we had to sub that out, but we do sub stuff out quite often. We just don't have the large enough facility right now to have all the machines, so sub it out, and we still make money off of that. So we're able to mark it up a little bit, cover our costs and time and so forth, but allows us to do the big job and just sub out this small portion. So this is 2 pieces here. I've got one in there. That'll make 3 10-foot pieces, and then over here we have another little 5-foot piece that'll make the long one there. So you've got this, and then laying right on top of it is the other piece. This will stand up and make a U shape. This is the 2 that go with the 2 long ones there. That's drop. I'm gonna have to cut a cap out because that piece there is capped on the end. And then we've got this one pretty much put together. We got this done, what's today? This Thursday? Today's Saturday. So I worked on this a little bit yesterday along with a couple other things. And what we've kind of done is we set up a little jig. Y'all know we like jigs here. So what we did, we took the L-shaped piece. It's a 24 on the bottom, 28 up. So basically we ran the 24 here and 28 up, and got it set in place. And then we use this because we're doing a corner weld. This is just a spacer to space up this piece that goes this way. We set it in here and just use these to clamp it to, and then get it all tacked up. It's not quite as easy as you would think. When we plasma cut those, it kind of puts a little heat into them, so it distorts those slightly, and we have to kind of get them straightened out using some little pry bars and so forth. And then once we get it tacked together, we come in, put these in. That keeps our spacing perfect. And then we run these. These are actually kind of just braces. As you saw out there, what they did, they actually broke all that and formed it. I wasn't going through all that trouble. It's not worth it. this is gonna work just fine. Plus this is stainless. This will probably be here after I'm dead and gone. If that lasted 25 years, you know, being steel, this should last 50 or 60 years, every bit of it, if not even longer. Like I said, it's in water all day long, but it's not the like really bad stuff that comes from the sewer. It's the end of the line. Supposedly when it comes out of this section, you can actually drink it. It actually goes and dumps into a local river, because it's, like I said, it's already been processed. So, anyway, so you see this, I'm gonna do the exact same thing on the other side, and I've already got the pieces cut and drilled. Basically what I have to do is cut these angles, and then I mark them all, lay them all out. Got 4 holes in this one, 4 holes across the bottom, 4 holes there. They've got some kind of gasket. We're not doing that. They're installing this, luckily, because they've got a crane and so forth already there to do it. And so they've got the gasket material. We just got to make sure all the holes line up. I drilled them 1/2 inch using 3/8 anchors. 3/8 bolts, I'm sorry. Probably all stainless. And that way we've got plenty of room, just in case we're off a little bit or something. They're able to get it all to line up. So I'm gonna set you up down here and get these pieces clamped on. I'll show you a little MIG stainless steel welding. So what I'll do is just kind of eyeball it, plant it, and then I can actually take a hammer and just tap it to get it perfectly lined up. Should be 2 inches on each side.
And then what I want to do is, once I get it perfectly even, symmetrical, I want it to be flush with this lip, because basically you're going to have these bolting together. You want all this flush, and I'll put the gasket material in here. You want to make sure you're flush all the way across. Pretty good. Once I got that on, I'll put another clamp. And then the next ones I can just set them right on here, and then go to the top, and it should be flush with the top here.
And then what I do is flush up the bottom with this other piece of angle I just bolted on. Tight. Stainless MIG is, or any kind of stainless really, you switch to a different type of metal, it's just different. You have to learn how to kind of watch the puddle and control your heat, and your settings are going to be different. So it's just something you have to practice. So now I've got both sides on the back of the angle done. I'm going to do the front, and I'm just running downhill. People talk crap about downhill welding, but it is absolutely fine. And what I'll do is I'll do the front here, but it's you know, the front here, but it's got to be grinded. I'll show you in a minute. I've got the other side done. I've got to grind it because you'll have them joining, so there's going to be a seal in there. So we've got to have that off completely flush. Off the sharp corners, and this one will be at a standstill. The angle that comes off here, we've been waiting almost a week. Most everything we use is pretty readily available. Unfortunately, this has been ordered, like I said, it's been about a week. Today's Saturday, it'll be here Monday. So we got 6 on each side, 14 inches long. And you'll have 2, 4, 6, 8 holes to put in. That'll be for the splash flaps, I don't know. Whatever the things are that fold down, because the water comes in actually through a pipe, comes in to here, and then it's capped at the other end, so it fills up and then flows over, and that's the ripple things go here. So we've got a plasma cut holes. We're not going to drill them. We can plasma cut them for the flaps, and then we've got some little pieces to put up here for in between, and we've got angle to go here with the holes in it. So we'll get that done Monday, but I go ahead and get this grinded, and then what I'll do is I'm gonna go ahead and set one of these up, have it ready to go Monday morning. A lot of people don't pay attention to the details, and something as simple as taking a flap wheel. Now grinding this has to be done no matter what, because they're gonna have a seal here. Like I said, this has to be watertight. So the water stays in it, just doesn't pour out these cracks or these joints. And so this has to be grinded no matter what, but taking a flap wheel and rounding these corners so it's not a sharp edge, running over some of the welds, you know, just to make sure there's nothing, any burrs, a little piece of wire, anything like that, because when they're installing these, they could hit it with their hand and cut themselves. So it's not just a matter of looks, it's also for safety. But you know, a lot of mine is just looks. It looks so much better. Just hit that with a, you know, round it just a little bit. Just the little small things that make a huge difference. Blend this whole thing together so it looks a lot more professional, and that's what I'm after. So you know, the key is to have nice, pretty welds. Make sure they don't leak in a situation like this, and then also just kind of, you know, finesse a little bit. And so that's what I like to do. So that's what you're seeing here. Get this grinded flat so it seals, and then finesse it a little bit, and add those extra touches that maybe somebody else doesn't do. of overhead cranes. Just make do. Just do it carefully. Stay that heck out of the way. Make sure you have an exit. Get out and run. If you need to. Not super heavy. I mean, it's heavy, but it's just awkward. So I call this a plate dog, plate frame. Called the plate dog, but it's your best friend when you're by yourself. Trying to find the center here. You don't want to tilt them one way or the other. Find the center. Pretty heavy capacity on this one. And it'll do 3/4 inch thick. Plate, 3,300 pounds, 3,300 pounds. You don't know that's a lot. force my clamps right in, buddy. CM, made in Britain, cam lock, awesome product. 3,300 pound, 3/4 inch capacity. They make them bigger, up to an inch, inch and a half, two, probably a couple thousand pounds more than that, but they're awesome. Basically, it's got teeth on that, and so basically what it does, it squeezes it, so when you flip that over and locks it in there, you know, this thing is kind of like spring loaded, so if you stick your finger in there, it's going to hurt. Basically, it's got a spring, and when you pull up on it, puts pressure and those little teeth bite in. So it'll leave a mark, a little bit of mark there, but it's not bad. Nothing you can't buff out. Flip it over. We just put this little chain on because it's easier to hook to the little hoist or wrap around the fork on the forklift. All right, so you kind of went backwards there. What you just saw loading on the table from outside was the L-shaped piece that we had bent. Subbed that out, had another company do it. This is 1/4 inch stainless. I think they've got about I don't know what it takes to do it, but they've got about a 350 ton press brake, and it's like 14 or 16 foot long. I think you can get away with less than that. Yeah, I don't think you need 350, probably 200, 250 plus to do 1/4 inch stainless, especially 10 foot long. So this is what it looks like. We've still got some more work to do to get this jigged up. We've got a spacer here, 1/4 inch piece that spaces this up, so it gets everything perfectly in line, and we do a corner weld. So this will come over just a little bit. There's a gap here, and you'll have a corner weld, and then we kind of just hit it with a flack wheel. It kind of blends it so it looks like the other one where it was bent. This is the best way I found to do it because you cannot get material and make it all in one piece. So it's got to have joints in it, but this is where we're at. These are uprights to hold this. We'll clamp it, and then we'll put some spacer bars in between to wedge it apart. Well, not really wedge it, kind of hold it in place more so, but, and then we'll go from there. So I'll try to catch that part so you can see that, how it's done. And that's pretty much it. We're going to mock this up, make 3 of them. One's just a little bit longer. And then I'll show you the little pieces, the anti-splash, or what are those, splash flaps? I can't remember what they call them, but anyway, the water comes over those ripples, hits those, and there's sand in the bottom, and what that does, it keeps from eroding that sand, so it hits those and then just disperses, and so that's it. But anyway, so we'll see what we can do on the next piece and catch you up so you can see how the braces go in and everything gets welded up. So what I'm gonna do is drill my 3/16 holes first on everything. It's just easier. It's quicker to take that out. Stick something in your finger there. It's quicker to just take the piece of angle out than it is to swap the drill bit repeatedly. So you can eyeball this. If you turn your bit where the flat side's to you, I can pretty much just about get it down there as close as you can without touching right over the top. And I can just about get it dead on. This mill here is off. It's pretty much a glorified drill press right now. It's just worn out. We bought it this way, and just not worth doing anything to it. It's just not worth it. We got another one we use for light machining and drilling, or making notches and slots and so forth.
And so what happens, I can get it really close, and then that little center punch we put in it, make sure you keep playing forward, and you see yourself spinning here. That little center punch allows it to time the tip of that drill. So if I'm off just a little bit, it's okay. Let's go again.
Difference in the bits, but you see the longer ones, the longer chips, not the little bitty ones like that. So we've got a nice clean cut we're making in there. So it actually continues to cut constantly instead of just a dull bit that may have sharp areas on it, but it's going to cut a little bit and it'll break off, cut a little bit and break them off. All right, so we got the two 10-foot sections done. This here is it's 15, but it's actually just short. It's 178.5. And so basically what we've done, same exact thing as the 10-foot setup here. We just had to add this little 5-foot section on the end. So this one's a little bit tougher, and it's gonna be a bear to get out because the other is just barely, you turn them sideways, and as you saw, they just slip right out the door. Got this one tacked together. We're gonna bevel these just a little bit, weld them up. We'll leave most of the weld exposed because of the application. We'll just hit them with a flap wheel. But as you can see, we've got these kind of here, holding it and spreading it and keeping it all square. We're within about 1/8 of an inch being square, crossing there. So I'll show you the other two we've got done. It's a beautiful day in North Carolina. I don't know what the temperature is, but it's sunny and absolutely beautiful. So these are the other two. As you can see, we don't have pieces here yet. This one is where it bolts to the concrete wall where the pipe comes out with the water. This one is the middle section, so this is normal, but what I've got to do is I've got just got done drawing up 4 by 28 strips with 1/2-inch holes spaced evenly. That'll go on both sides. That'll go to the wall. Then this section here will bolt coinciding angle here. That'll bolt together. And then the long piece we've got in here will bolt up to that. So only thing left to do to these is the angle. I'm still waiting on it. It's supposed to be here today. It's been like a week or a week and a half now. It's 3 by 2 by 1/4 stainless steel. And that'll be the pieces that come out here. And that's for the, I don't know what they call these things, anti-splash guards maybe, because the water comes down through here. Of course, these are together and sealed. The water comes, fills this up and flows over the sides, and then it hits those so it doesn't wash out the sand. So what we've got to do is cut 14-inch long pieces, 6 on each side for the short ones, 9 on each side for the long ones. And then we got to drill holes. They've got holes in all of them, but I spoke with the guys that run this plant, and he's like, yeah, there's no point because there's no bolts there. I think that was just when they built these originally, they just drilled them all. Well, when drilling steel, it's not that bad, but drilling stainless, I'm gonna alleviate those holes because that's a lot of drilling unnecessarily. That's unnecessary to be done. So the one on the end here and there, those will get drilled, the middle one will not. And we'll get them put on, and that's it. And they're coming sometime the next day or two to pick all this stuff up, because these are aluminum. They're definitely worn. They've seen their better days, but they're going to reuse all those. There's nothing wrong with them. And the little ripple guards or whatever they call these things, they're going to reuse those. These are actually fiberglass, kind of interesting, but not sure why they chose fiberglass. I don't know why not aluminum on that too, but anyway, so different design. You see they've got cross braces here. That was actually an afterthought, because what happened, this one actually bolts to the wall here. You can see the bigger flange because the pipe that comes in hits the bolts if you make them like this. So these are kind of, like I said, they're falling apart. They've done their job, but the water pressure, because there's so much water, was pushing out on the sides. So they came back in later in life and added these cross braces. Well, we just kind of came up with our own design and changed things up just a little bit, simplified those, and just put angle in here. So now there's no way in the world they're going to come apart. These things are super, super stout. They came by today, and he was just tickled to death of how they look so far, and can't wait to see it installed. So there you have it. Get this one tacked up, put the angle pieces on. We got them cut, and we'll be welding this up. And I've got the plate on the plasma table. She's ready to go. I'm gonna cut the end cap, which will be a 23 3/4 by 28 rectangle, and then I'm also going to cut 2 of the strips. I was going to go ahead and cut, because we've got more of these to do. but he wanted me to hold off just in case something needed to be changed. They want to run one. Like I said, they've got 6 of these units total, and this is just one. They want to run it, make sure it works, and then I'll use this drop sheet for the other. I'll probably get 3 or 4 more of the end caps and the little flange pieces, I'll call them, where they bolt to the concrete wall. So we'll get back at it here in just a few minutes. We just finished these up today. So hey, these are ready to go. These will be delivered tomorrow morning. These actually bolt together to make a 35-foot piece actually. And over here on the trailer, finally got all this crap cleaned up. We had stuff everywhere over here. This is the long section. It's loaded. I can only put, because of these pieces that hold the splash guards, that bolt to that and fold down, I can't mount, or I can't get anything else on here, so I just haul this one. Luckily it's local. Haul that one over there. This is an 18-foot trailer. My next goal is to get a deck over, I think.